You know, the animal kingdom is just bursting with this incredible, mind-boggling variety of life. We're talking from the deepest parts of the ocean to the highest mountain peaks. But here's the fascinating part. Underneath all that amazing diversity, every single animal, from a tiny beetle to a massive blue whale, is basically facing the exact same set of core challenges. So today, we're going to open up their universal toolkit for survival. And just to give you a sense of the sheer scale we're talking about, get this. If you could somehow gather up every single animal species we've ever described and put them in one place, 1 out of every 4 of them would be a beetle. Yeah, a full quarter of all known animal life comes from just that one group of insects. The level of diversity is it's staggering. And all that variety, it brings up this really central question, right? You've got millions of unique species, each with its own incredible form and function. So how does every single one of them go about solving the exact same fundamental problem? Just staying alive? Well, that's exactly what we're going to break down. Okay, but before we can even get into the cool, specialized tools that animals use, we first have to understand the basic chassis that evolution has to work with. These are the fundamental body plans that really set the stage for everything else that follows. And it all starts with a concept you probably remember from art class, of all places: symmetry. In biology, this just means the balanced way body parts are arranged. And it turns out the deepest, most ancient splits in the entire animal family tree, they happened because of simple shifts in this very concept of body symmetry.
So here we see evolution's 2 dominant approaches. On one hand, you have radial symmetry, like this brittle star. Its body parts are arranged around a central point, kind of like spokes on a wheel. This is perfect for sensing the world, danger, food, you name it, from all directions at once. Then, on the other side, you have bilateral symmetry. Think of the grasshopper. Its body can be split into 2 perfect mirror image halves. And the absolute game changer here is that this design allows for a head, a place to concentrate all your sense organs right at the front. And that completely changes how an animal moves through and interacts with its environment.
All right, so with those basic blueprints in mind, now we can really open up the toolkit itself. We're going to look at some of life's biggest, most universal challenges and the absolutely brilliant, specialized tools that different animals have evolved to solve them. First up, a problem every single animal has to deal with. How do you get from point A to point B? I mean, whether you're chasing down dinner or you're trying to escape becoming dinner, being able to move effectively is totally non-negotiable. And this shows 2 completely different but equally amazing solutions. If you need pure raw speed, you look to the cheetah. Its spine is so uniquely flexible, it basically acts like a giant spring, coiling and uncoiling to launch it forward with a massive stride of up to 9 meters. But what if speed isn't your goal? What if you need to, defy gravity? Well, the gecko takes a totally different route. Its feet aren't sticky with some kind of glue. No, they're covered in millions of tiny microscopic hairs that create a very weak attraction at the atomic level. But when you have millions of them working together, that force is more than strong enough to let it just walk right up a pane of glass. It's incredible. Of course, all that running and climbing burns a ton of energy, which leads us directly to our second universal challenge: finding and eating food. And again, evolution gives us this wild range of tools for the job. You've got the flamingo, which is a pretty passive filter feeder. It uses that uniquely shaped bill almost like a sieve, pumping water through with its tongue to trap tiny bits of algae and little animals. Now compare that to the spider, a very active predator. It doesn't even bother chewing its food. Instead, it injects this potent venom that does 2 things. It paralyzes its prey, and then it liquefies its insides. It essentially turns its victim into a pre-digested smoothie that it can just drink up. Pretty wild, right? So, if you're out there trying to find a meal, you've also got to make absolutely sure you don't become a meal. And that brings us to our final big challenge: self-defense. Let's look at 2 genius strategies here. First, the 3-banded armadillo. Its solution? Turn into a fortress. Its bony armor is hinged, which lets it roll into a nearly perfect, impenetrable sphere, protecting all its soft spots. Then you've got the panther chameleon, which just opts to disappear. But this is the really cool part. It's not using pigments like paint. It actually has tiny crystals embedded in its skin. And by using its nervous system to control the spacing of these crystals, it changes how light reflects off its body. This lets it shift from a relaxed green to an excited red in mere seconds. It's basically a high-tech active camouflage. So, look, Having a great toolkit is one thing. That's fantastic. But those tools are pretty much useless if you can't actually perceive the world around you. And this is where nature's incredible guidance systems and sensory superpowers really come into play. And we're not just talking about good eyesight or hearing. Animals have evolved senses that feel almost like magic to us. I mean, they can literally see heat in the dark, they can detect hidden electrical fields, and they can feel the vibrations of prey from far, far away. Take the python, for example. It has these special pits along its lips that are just packed with heat-sensitive receptors. This basically gives it a thermal image of its surroundings, letting it see the body heat of a warm-blooded mouse in complete and total darkness. Skates have an equally amazing, almost alien ability. The bottom of their head is covered in these little pores that lead to jelly-filled canals. These canals act as super-sensitive electrical sensors. They can pick up the tiny electric fields generated by the muscles of a clam that's buried deep under the sand. They can find food they can't see, hear, or even smell. And a sea lion's whiskers? They're not just for show. They are incredibly sensitive instruments. They can feel the tiniest disturbances in the water, the wake left behind by a fish that swam by moments ago. This lets them track and hunt their prey just by feeling its ghost trail in the water. So all these incredible tools and these sensory superpowers, where do they all come from? They didn't just pop into existence out of nowhere. No, they are all the products of the master engineer behind the entire toolkit of life itself, evolution. You know, more than 150 years ago, Charles Darwin used this powerful metaphor of a great tree to describe how all life is interconnected. He said that every species is like a branch connected to all the others in the past. And that one beautiful idea really explains all the patterns we've just been looking at. And that's really the key takeaway here. Every single adaptation we've talked about, from the cheetah's spine to the chameleon's crystals, is a new branch on that tree. None of this is random. It's like a massive library of unique, brilliant solutions to the shared problems of survival, all of them refined by natural selection over millions and millions of years. Which of course leaves us with one last, really fascinating question to think about. This whole process of evolution. It's always at work. It never stops. So as our planet changes faster now than ever before, what new tools, what new solutions is evolution inventing right now for the next chapter in the amazing story of life?